here we go, folks. So we're looking at chapter 14. Now, chapter 14 is not a super long chapter. There's not a ton of stuff for you to get done in here. There's like 5 lessons. We space it out. We give you lots of time, so we make sure that you have the opportunity to do a nice job on this. There's no retakes on this chapter. There's just no time. So you take the test on the 28th, and then you have a final exam review, and then you have 2 more days, and then you have finals. Okay, so there's just no time. So just make sure you're doing your diligence, and don't stress about it either, because as long as you do your work, you'll be just fine. So seniors, just work on your final exam review. The chapter 14 portion of the final exam review, just rip it off and throw it out. You don't have to do that portion. Okay? So here we go. Now, suppose we're going to go to Grandma's house. Over the river and through the woods, off we go. It's 200 miles away. If we travel 1 mile an hour, how long is it going to take us to get there? Okay, come on. If it's 200 miles away, you go 1 mile an hour.
200 hours.
Okay, thank you. That one wasn't supposed to be the difficult question of today. Okay, what if we go 2 miles an hour? Crazy, right? All right, here we go. What about 10? We're just going to go like this, hours. I'm going to now label it after that. What about 100? What if I went 200 miles an hour?
You pull over.
Well, it's probably happening at 100. Unless you're in Germany, then maybe not. Just 1 hour. Yeah. How are we getting those numbers? How? Division. Yeah. What are you dividing? Yeah. The miles by the miles per hour. So our function would actually be this. We could say f of x equals 200 divided by x. Whoa. You know all those nasty problems we were working with in chapter 13? This is kind of why. So like one of the applications of those problems is time and distance, speed. There's a relationship there. So we get a rational function coming from that. So this is one item that we look at. This is just a quick example of where you might actually see it. We're going to continue on with this example and look at something else. What happens if we would graph that? Now you just made a data table here. We have a graph right here. So if I went 200 miles an hour, right? How long does it take again? Your data table's right there. If you went 1 mile per hour, how long does it take? 200. So if I go 1, so I'm going to be pretty close here. It's not going to be right on the y-axis, but it's pretty dang close. 200's right there. And if I go 200 miles an hour, how long is it going to take? Just 1. Yeah. So I'd be like somewhere down here. And then we have the points in the middle. If I went, 10 miles per hour, that'd be my first tick mark. How long does it take me? 20. So I'm right there. And so what I want you to realize is we're making this curve. And it's a weird looking curve. It's actually only half of the curve. And we'll get into why it's only half of the curve when we graph this one. Because we have constraints, because we know things about the situation. What happens if I go 0 miles per hour? Well, when will I get there though? Never. But isn't that kind of weird? What happens if you do 200 divided by 0? What's that? Not 0. It's undefined. And that's why your graph actually never touches the y-axis. It's never going to be 0. So there's something to think about there. Now, what if you went negative 100 miles per hour? If we look at our function, that'd be negative 2 hours. Now, I don't know about you, but if you could drive backwards in your car, or if you could somehow get a negative speed, I think everybody would be doing that. Because if I could drive to work at negative speed, that'd be kind of nice. Or maybe not, because then I'd be at work longer, right? So, I don't know. Maybe not. But obviously, this doesn't work out. Now, we get a number for our function, and there's a time and a place when we would actually use that number. But for this distance graph, it's not going to be there. But my point is that you also have a graph that looks like this. We choose to ignore it when we're looking at the distance and the speed and stuff because it doesn't apply to the problem. But it is there. And so we're going to explore functions that look like this today. They're kind of interesting. So go ahead and flip the page. And you don't have this, or actually you do have this. Never mind, we added it. We didn't have it before. So we have rational functions, and basically they have x's in the numerator, they have x's in the denominator, but the big thing is they have an x in the denominator, okay? But they got x's all over the place most of the time. And so we are going to graph these things. You worked with these in the last chapter, and you looked at them just from the lens of algebra. Now we are going to shift that and look at them from the lens of the graph. There's one connection that I want you to make, though. What's my restriction here? X cannot equal. What's this? What's that factor to on the bottom? Oh, get snappy. Yeah, x plus 1, x minus 1. So that means x cannot equal what? Perfect. I'm just going to put plus or minus 1. Same thing. And we could do the next one. I'm not going to. I'm going to do the top one, though, because we always forget this one, and say x cannot equal 0. Well, there's a reason we have those things, and they show up as something in a graph. If you can never have x be something in a graph, does anyone remember what that is on a graph? How did you pay attention? You get to work. All right. Okay. All right. We get asymptotes. We get these imaginary lines that aren't actually on your graph, but if you cross those asymptotes, you graphed it wrong. And you're like, I hate those things. I always go over the line and Nichols always takes points off. You're not wrong, because that's true. We are going to basically figure out how to find our asymptotes. For rational functions, they're kind of like a fence post. And if we know our fence, we know how to graph it. You actually don't have to find a lot of points. You find basically 1 point, and then you know where the function is in terms to your graph. If I have a dot right here, I can just follow my fence and curve through it, and I'm done. So we spend our beginning lesson on how to find the asymptotes. So let's take a look here. That's painful. This is actually my probably favorite unit because we play Who Let the Dogs Out. It's a fun lesson. A couple weird ones, not many. All right, so let's just draw in our imaginary line. Where's the imaginary line for the third graph in the upper right? What coordinate would that be at? Not 1, look at your scale. 2, yeah. So we would have a dashed line coming through here. Where else do you have a dashed line going? 0 for the y's, yeah. So you're going to have horizontal and vertical. Now, we don't just have horizontal and vertical. You can see a couple more. We're not going to get there. You also have a glorious slant asymptote. So now we have our graph that follows this line, but then it has to curve away. And so this is the first time you've seen a slant asymptote. But there is all types of asymptotes, so buckle up. Those are the only 3 we have to look at. So let's actually just get into this. I'm going to slide one more page. I'm going to slide past this. And we're going to talk about the horizontals to begin. So we're talking about the y. First one, y equals 0. What degree is the top? How many x's do I have up there? I don't have any x's. How many x's do I have on the bottom? 1. Now, I'll give you another example. Write this one down. What if I have x and x to the 5th minus 2? Do you know what my horizontal asymptote is? Y equals 0. And we just say this. We say that we are looking at small divided by big. And we are just talking about the degree. So the degree of the top is smaller than the degree of the bottom. If that happens, then you have a horizontal asymptote at y equals 0. No work required. You just do that and you're done. Now the next one. What degree is the top? 1. What degree is the bottom? 1. So we have the same. So the degree is the top on the, or is the same on the bottom and the top. Now, all you do in this case is you take those two numbers right there. So the 4x and the x. And I divide them. That's gone. So my asymptote is y equals 4. Some of you might be looking at that and you're like, that's actually not that bad. Oh, just wait. Now, one more example of this would be if I had 5x squared plus 6x, and on the bottom here I had 7x squared plus 9. What degree is the top? No. 2. We only care about the leading one. Okay? So it's 2. This one's also 2. My horizontal asymptote from this is y equals 5 over 7. Okay? We aren't really going to give you one that bad because we want our graphs to look nice so that when we grade it, we can see this ugly slop and just be like, that's wrong. Okay? We don't have to spend our time looking at it. But that's what we got. Now the last one, slant asymptote. Oh my goodness gracious. Reagan, go in. Nothing makes you feel more like a boomer when technology doesn't work. There we go. Last one. Adam. You guys remember a YouTube we watched where this guy kept talking about Adam? Adam shaking his head yes, but I don't actually know if he remembers. Do you remember? What was something he did that was kind of weird in the video? That's true. He drew his flower. Guess what's coming back? No. Synthetic division. Or if you would like, we can just do long division. No? Yeah? Some of you are actually like, yes. If you want to do long division, do long division. Otherwise, we're going to do synthetic. So I put my coefficients here. 1, 4, -9. What goes on the outside here? Is it 2? Is it -2? -2? Nice. All right, people, don't disappoint me here. What's your first step? What? Yes, you drop it like it's hot. So we drop it like it's hot. Drop the 1 down. You said it too quietly. All right. So now what? Okay. Now what? Add them together. Now what? Multiply. And oh my goodness gracious, look at that. We got -13. You're just like, Nichols, that did not work out. Well, guess what? It's never going to. Okay, if it does, you don't have a slant asymptote. So we don't care about that. We just say that y equals 1x plus 2. Where's that -13? We don't deal with it. We don't worry about it. That's your slant asymptote. Goes straight through. So if you have the case, what degree is this on top? I'll come back to it. Where's this come from? What degree is that?
1.
No, 2. That's
1.
so whenever you have big over small, you have a slant asymptote. Now, the 1 and the 2. That's it. Okay? Remember, it starts as x squared, it drops a degree, it becomes x.
So the first number is always going to be 5x.
Yes. Okay? We actually, and that's a good recognition right there, is because we are doing these problems in a way that is kind of set up to make this happen, we don't have to worry about anything crazy happening. This is always going to be an x. Okay? Always an x. And then it's always a constant, and then I could care less what my remainder is. Okay? All right, flip the page. All right, vertical asymptotes we actually didn't really talk about yet, and it's because you've been doing them for an entire chapter. So, what, for this first function on the left, what is my restriction for that problem? X cannot equal what? 0. Guess what? That is your vertical asymptote. X equals 0. And so you draw a line straight up and down, that's dashed. And I'll even put arrows on it. Now, do we have big over small, small over big, or same over same? Small over big. So what's my horizontal asymptote? Come on, this is the easy one.
0.
0, yes. Horizontal asymptote, y equals 0. What makes my denominator 0?
So we don't have to draw a line for that.
Oh, I didn't draw a line. You got to draw a line. Jumping the gun there. Thank you. Okay, next one. What is my restriction? 5. So x equals 5. And I go my line at 5, somewhere like right over here. Boom. What is the case that I have? Small over big, big over small, same. Small over big, so it is y equals 0. All right, next one. What makes the bottom 0?
1.
Negative 1. All right, so x equals negative 1. What's our case? Same. So that means that I just look at 3x divided by x. Cancel it out. Got a horizontal asymptote at y equals 3. Okay, next one right here. What is our degrees? It's going to be the same. Okay, so you got x squared and x squared, so it's same. Now I skipped out over the vertical for just a moment on purpose. So we have our same here, so I'm going to have negative 4x squared divided by x squared. Cancel that out, and I get y equals negative 4. It's horizontal. Now, what makes my denominator 0? And 1 and negative 1. What I like to tell people is there's two ways of looking at this. One, I can always factor that, so I can say that this is x plus 1 and x minus 1. Now, sometimes that screws people up when they're looking at degrees, because I've changed this from standard form to factored form, so then I actually do have to count all the x's. The other option is just take your denominator and set it equal to 0. And if you do that, you should get x squared equals 1. You take the square root. If you don't walk away with a plus or minus, that's painful. So we actually have 2 here. We have x equals plus or minus 1. And so I will have a dashed line right here. And I will have a dashed line right there. You can have 2 vertical asymptotes. Questions? All right, we're going to do this one right here. Vertical asymptote, what is it? 1. Now, pause yourselves for a moment. If I write 1, is that good enough? No, you need to know your x's and y's. Okay? Vertical is always the x. So you better believe you got to write it. So x equals 1. Now, what is our case here? The big over the small. It is a slant. Which means, Adam, you sleep. It was a good time. We have to go ahead and do some synthetic division. What number goes on the outside? 1. And then I'm going to have 1, 3, negative 7. And if you bring a flower back, maybe it'll give you extra credit. I'm just kidding. We both know it won't. Yuck. That was not even a line. Right. That's better. Questions? I want you to do the one that is directly below it. This one right here. What makes the bottom 0? 0. That's it. So it's just 0. So I got x equals 0. What's my case here? Small over big, so what's that? Yep, y equals 0. Let's do one more. We're going to do this one. 2x squared minus 3x plus 1. I'll tell you right now, you're going to get a slant. Find your vertical first. mistake was. And you got it. Good job. All right. What questions do we got? All right, go ahead, jump into